figures. What does it mean if something is similar?
Almost.
Kind of the same, right? You are all similar to each other, but you are not exact unless you have an identical twin sibling, which means you share DNA. Okay? As far as I know, none of y'all have that because I would teach them. Similar figures. It's what's right here in front of Caden on the board. Similar figures. So if you're online, you can write this down because you can't see. Connor and David. Same shape, same angle. The sides are proportional. That's it. Same shape, same angles. The sides are proportional. That's also what it says up here on the board. Just kind of a little fancier. So we're gonna this whole lesson is on similar figures and scale drawings. Okay, we're gonna start with similar figures today. We'll do a little bit of scale today. They're the same shape. They are not the same size. If they are the same shape, same size, and everything's the same, what's it called? It starts with a C. Does anyone know? Yes, that is right, Gracie. Good job. Congruent. So similar. Figures that have the same shape but are not the same size. The figure for similar is that little squiggly thing right there. They have corresponding angles. That means this angle is the exact same as this angle. Are you with me? This angle is the exact same, but then you use proportions to solve problems involving similar figures. Do you know how to solve a proportion? You do. Good. We're also going to touch on scale a little bit today. We're not going to do a lot today because we'll do more in the next couple of days, but I'm going to read what a scale drawing is. So I'd like you to read along with me. A scale drawing is a proportional two-dimensional drawing that is similar to an actual object. Scale drawings can represent objects that are smaller or larger than the actual object. This is real life. Like, when do you think you might use this? When?
Every day.
Okay, give me an example.
Like an art museum.
What'd you say?
I was going to say building.
Building a house. What are those things called that you have drawn up? Blueprints. You do not make a blueprint the size of a house. That's ridiculous. You might as well just build a house, right? You make a small drawing of it. When else might you use it? What'd you say, Maddie? What'd you say, Silas?
Math class.
When else do you think you might use this in the real world? Yes.
Maybe at a bank.
Why at a bank?
Or work.
Huh?
Or work. Like welding.
Building
Like
a car or something like that.
Building like cars. Yes, you might build a car. What if you wanted, you might use this in science class actually. What are some things that you draw in science that are a lot smaller than what you draw?
an animal.
Cells.
Cells, yes. People use scale drawings all the time. I know you're probably not going to draw a cell when you go, build your house, but you know what I mean. All right. We're going to go all the way to the bottom here, and we're going to try to figure out if these two things are similar. It's pretty simple. You just set up a proportion, and I like to kind of draw my line right in here, so y'all just watch me. I'm going to put 32 over 24, and I'm going to put equals 20 over 20. Y'all can probably look at that and tell if it's equal. Is it equal?
No.
No. So these are not proportional. That's it. All right, turn the page. When two figures are similar, the ratio of the lengths of their corresponding sides are equal. You try. Are the two polygons similar figures? What is a polygon?
Upside down triangle.
It's a shape. Can you be more specific? That is closed and has. This is a polygon. Three or more sides. Good. So we're going to set up a proportion. I'm going to kind of just make my little proportion like right here. Kind of give me an idea of what to write. I'm going to write 2.8 over 2. And then which one goes with 2.8?
7.
The 7. 7 over 5. And then we're going to figure out if these are equal. Do you remember this? Like, this is 14?
Oh, yeah, the butterfly.
Butterfly, that's right. Then y'all do 5 times 2.8 and tell me what you get. What is it?
14.
14. Are these similar?
Yes.
Yes, because those two numbers are the same.
That was my 4th grade.
I know. So number 4, this right here, 4, if you have 2 figures that are similar, then you can use proportions to determine a missing side length. I'm going to read this here. And you look up here so you know what that says. In the figure below, triangle ABC is similar to triangle DEF. What is the length of X? So right here, you have to use X. What number corresponds with X?
12.
12. But you can pick which number you want to use on the other one. You want to use 16 or 20?
20.
20. So I'm going to kind of box that one. And who goes with 20 over here?
10.
So you have to use the 10 if you use the 20. Do you see you have to use the corresponding sides, right?
Is that?
Anyone want to try to write what the proportion looks like? Go ahead, Kyle.
20 over 10.
You can do it that way, but I like to put the shapes here, but you can do 20 over 10.
Then 20 over X
Perfect. Equals
equals 10 over 12.
10 over 12. That's it. You can do 20 over 10. You can do it like this. Where does the X go? There you go. You will get the same answer. Okay? Can you cheat here?
Yes, ma'am.
You can go backwards, right? Times what?
2.
If you do it upstairs,
You're downstairs.
you do it downstairs, right? So what is it?
24.
24. Pretty simple, yes?
Yes, ma'am.
All right. Turn a page. You try. The pairs of figures below are similar. Find the value of each variable by setting up a proportion and solving. So this, you have to use the numbers they give you. Who would like to try the proportion? Thanks for volunteering, Gracie.
4.5 over X
Perfect.
equals 6 over 10.
Perfect. I wrote Y because that's what that says. Is it okay that she said X?
Yes.
Yeah. Can I cheat here?
Yes. Or no.
No. So I cross multiply and I get 6. Y equals 45. Now y'all solve that. Nathan, are you working? We're supposed to be solving this one on your paper. What do we do from here?
You divide by 6.
Divide both sides by 6. Good. And you're just going to have to work it out, right?
Yes, ma'am.
I believe it's 7.5.
Yes, ma'am.
Good. Yep, everybody good?
Yes, ma'am.
Look at the practice. Number 1, the front of Jane's house is similar in shape to the front of Spot's doghouse. The base of the doghouse is 5 feet and the height is 6 feet. The height of Jane's house is 30 feet. What is the length of its base? Who would like to try the proportion? Sierra.
30 over X equals 6 over 5.
Perfect. Can you cheat here?
Yeah.
Yes, by 5.
Yeah, you're going backwards. Multiplying by 5. What's X?
45, 25.
Perfect. This is not too hard, I don't think. Do you think?
Yeah.
Let's look at number 2. An adult 6 foot tall has a shadow of 3.6 feet long. How long is the shadow of a child 5 feet tall? Oscar? Tell us the proportion.
$30 over Y.
We're on number 2. I'll let you do the next one, Oscar. Caden, what's the proportion?
6 over X.
Nope.
I meant, no, 6 over,
Guys, Caden,
oh, 3.6,
equals
5,
over,
6,
nope,
X.
can you cheat here?
No.
No, solve this, please. I'll even do the math for you. 3.6 times 5 is 18. Now what do you do?
Divide by 6.
What does X equal?
3.
3. Let's go to the next page. Go to page 5. I want you guys to do A and B there. Given that the figures below are similar, solve for each variable. David. David. Stop turning your camera off. All right, hey, Oscar, it's you, dude. What's the equal proportion?
8 over 2.5
Awesome.
equals 8 over 10.
Perfect. You couldn't cheat here, could you?
No.
So we had to cross multiply and get 2.5h equals 80.
Mhm.
Then what?
And you divide
By what?
by 2.5 and 10.
Good. So when we do this, we got to do, what do we have to do?
Go to decimal.
Move the decimal. So what'd you get?
I got 32.
32?
Yes, ma'am.
That looks right. 25 into 80 goes 3 times. Yep. Awesome. B. Peyton.
Over 12 equals 3 over 5.
Awesome. What'd you get for your answer, Peyton?
7.5.
Is it 7.5 or 7.2?
7.2.
I think it's 2.
I got just 7.
Well, that's 5x equals 36.
Oh, that's what it is.
Not 37. And 5, yeah, it's 36, so 35. It's 0.2. It's fine. You're close enough. Awesome. Let's look at the next one. A rocket casts a shadow that is 91.5 feet long. A 4-foot model rocket casts a shadow that is 3 feet long. How tall is the rocket? Jasmine, what's the proportion?
H over 91.5. 4 over 3.
Perfect. And we solve this by cross multiplying and we get 3h equals, I'll do the math for you, 366. Now what? Perfect. I got H equals 122. Questions there? Y'all are awesome. Let's go all the way. Let's look at the not page 5, page 6. I want to make sure that you understand sometimes they'll flip the shapes around on you. You still have to find the matching side. Page 6. So on number 9, do you see the X here?
Yes, ma'am.
What number corresponds with X?
5, 6.
The 5 does. See it's flipped around?
Oh, I see it.
See it?
Yes, ma'am.
And then here, do you see the X?
Yes, ma'am.
What number corresponds with X?
16.
The 16 does. You see how it's flipped around? Yeah, I'm not going to make you work those. I just want to point that out to you that sometimes you got to pay a little closer attention. Okay, and then a couple that are a little bit different now. We're going to look at, they're going to give you the scale, and you're going to figure it out. This is where they take the pictures away. Okay? Take the pictures away, and you got to use words. I've told you guys to use words first a lot. Here we are back to it. So number 11. A particular motorcycle is 9 feet long. A model of it was built with a scale of 1 inch to 3 feet. How long is the model? So the words I'm using are inches and feet. 1 inch is 3 feet. A particular motorcycle is 9 feet long. Where does the 9 go?
Bottom.
Good. That's pretty simple. What's the answer?
3.
3. Those are pretty easy, right? Am I going too fast? Number 12. A particular satellite is 15 meters wide. A model of it was built with a scale of 1 centimeter to 5 meters. How wide is the model? Centimeters? Meters. 1 centimeter is how many meters?
1 centimeter is 5 meters.
5 meters? This is satellite is 15 meters wide. Where does the 15 go?
On the bottom.
So what is it?
X equals 3.
Good. Make sure you get all that written down. I agree, it is easy. Okay. So on to the you do. We're going to talk about a few things before I turn you loose to do it on your own. First of all, on number 1, you see the X? That means you have to use what number?
3.
The 3. However, there are other numbers you can choose from. You can either use 10 and 40 or 14 and 56, whichever one you prefer. You got me on that?
Yes, ma'am.
And then I want everybody to look at number 4. To see the pictures are gone. I'm going to read it and I want you to read along with me silently. A 6-foot tall tent standing next to a cardboard box casts a 9-foot shadow. If the cardboard box casts a shadow that is 6 feet long, then how tall is it? If you notice, they are all feet, so you can't use feet and feet. So in these cases, I like to use the words tall and shadow. 6 foot tall, casts a 9-foot shadow. 6 foot tall, 9-foot shadow. With me so far? With me so far?
Yes, ma'am.
If the cardboard box casts a shadow that is 6 feet long, then how tall is it? Where does the other 6 go?
At the bottom.
Good. Words first will always help you. I'll let you guys solve that because I know you won't listen if I don't. And then I want to go ahead and look at number 5. It's another one just like it, but we're going to do that one too. Actually, there's some scale ones on here, and then there's some similar figures. Look at number 11. Go to number 11. A statue that is 12 feet tall casts a shadow that is 15 feet long. Find the length of the shadow that an 8-foot cardboard box casts. So we're gonna have tall over shadow. And we got 12 feet tall, casts a shadow of what? 15 feet long. And this says, find the length of the shadow that an 8-foot cardboard box casts. Where does the 8 go?
On the top.
On the top. Awesome. Is everybody with me?
Yes, ma'am.
It is only 8:24, 9:24. I'm just kidding. Which means you have time right now to work on this. You're finishing pages 7, 8, and 9. Finishing pages 7, 8, and 9. Those of you online, I expect it to be written on notebook paper if you can't print it. Worked out. No, we better not just have answers. You can write the proportions. But you can work on it right now. 7, 8, and 9.
They don't need that anymore, do they?
No, you can move. Somebody's phone ringing? Somebody's phone ringing?
No, it's Mrs. Curtis's sharpener.
It sounds like a FaceTime call. When is spring break? Somebody leaving? Hello, Miss Milliken. Nope, he is remote. Well, he never gets online, so can you tell her that? Thank you. Bye. Time to clean up. No. Connor, Nathan, and David. They have to use those papers out. I don't have them right now. Connor? Why do y'all continuously turn your camera off when I tell you not to? See everybody tomorrow, same time. Miss Sam, can you let your sister know what you missed?
Yes, ma'am.
Thank you. Bye.
Now.
Hello, Miss Wilson. Okay, so I was like.